Okay, so um, today we are going to take a look at some advanced build features in MPS, or how you can build MPS projects in a more sophisticated way than with the integrated build language. So we won't talk so much about details inside of MPS, but more on the surrounding layers. How do you composite a build, and how do you try to stick all the bits that you get from MPS together so that it works quite nicely in a bigger environment. So I assume that you have already some experience with MPS as build language. So I have a little sample project here that contains some build scripts already. But let's first take a look at the actual structure of the project. The project has two toy languages. The content doesn't really matter. In this case, they only contain one expression here. And the other one is empty. They are just there to demonstrate how dependencies could look like inside of MPS. Then there is a test solution that has some type system tests for one of the languages here. It's currently not building here because it's not up to date, but we will fix that in a minute. Then there is some other solution here that uses some external dependencies. In this case, it's jar files. We would also take a look at how we can manage these external dependencies nicely. We have a sandbox, which is just for playing around with the languages, so we don't really do anything with them in the build. And we have a runtime solution here. And this runtime solution is used by this language to demonstrate how we can actually get these things together in the build as well. So we already have quite some build scripts for the individual parts here. We also have a build script that actually builds an RCP, but that's also not. We will take a look at that later as well. So the thing that we have here is one build script that tries to build all the languages. Currently everything is red here because it has never been executed, so let's just fix that for now. Ignore the errors, and okay, let's remove this solution for now. Okay. Okay, this builds now, and we get the usual MPS build scripts out of it. So if we take a look at this output location here, open up here, and we check, we can see that there are now 3 XML files here. All of them are ARNT files, the usual ARNT files that you are used to from MPS. One of them for executing the tests, one of them for building all your custom languages, and the third one for building the RCP. We could now just execute them as usual by just invoking ARNT from the command line and supplying all the necessary parameters that we need to find the dependencies that we have. And these are quite a few, so let's take a look at them in MPS as well. So if we take a look here, the language that we have built here, this toy language A, is a language extension to IETS3 open source. So we have this as a dependency, and IETS3 open source also has a transitive dependency, or has a dependency itself on the Embedder platform. And so we have a transitive dependency. And in this case, MPS or MPS's build scripts will not handle them nicely. So they are basically, you need to supply the path to all of your dependencies as well. But this is all the normal MPS stuff. I won't go into all of these details right now because we want to look at some more advanced things, I guess. So this is all pretty straightforward from what you would have in any normal MPS build script as well. What is already a bit special is that we have a dedicated location where we store all of our artifacts. Why do we do this? So the reason behind it is that I would like to have one location in the repository where we store all of these files from our dependencies. So the artifacts, the jar files, the zip files that we have downloaded. For now, we can assume that they are put there manually, right? So somebody has to download these files, which are in the artifacts folder. We can take a look at them as well. So if we take a look at the artifacts folder, open that one here, we can see that it contains the two dependencies that we have. So the embedded platform with all of the sub dependencies, the jar files that are required, etc. And the same applies for IETS3 open source. So here you can see that the sub-projects of IETS3 are also in here. Currently, they are copied there manually, so somebody has to download the correct version of IETS3, place them in this folder, and then the build can actually pick them up. So this is something the user would have to do before he can actually start working with the project manually at the moment. The same applies for MPS. So if we take a look at the MPS location, I think it's not even set, I guess. Yeah, it's not set at the moment. So somebody from the outside world currently needs to fill in this variable with a real value for the MPS location. This would be something that the user would have to do at the moment. So when he wants to invoke the build scripts from the command line, he can do this by using and. So let's go to the actual location here. So if you would just run and -f build.ml file, I think it will fail. Yeah, exactly. So we should also invoke the generate task where we need an MPS. So here we can see that it failed to create a task because it couldn't find any of these custom tasks here. This is the typical error message that you get, so that basically this declare MPS task fails in case of you don't have a valid location of MPS. The error message doesn't tell you anything about it, so it only tells you that it's missing the task definition, but it's not telling you that you should take a look at your MPS home location. So let's take a look where my MPS is located on this machine. I think I have put it into the users folder. Yeah, exactly. So here you can see there's MPS 2018-2. And since it's a Mac, I think navigate into the folder. This one, then it's content, right? So if we now pick the path here with EW, and then what we would need to do here manually is do a -d MPS dot home equals, and I think since it has a space, like this. Yeah. So now the Anta starts, tries to generate our project, which will take a bit. And then the build eventually finishes successfully, yes. Okay, the same would now be true for the tests. etc. But we still have a lot of manual work to do. So we have to invoke AND directly from the command line to set the MPS location. The user has to manually download the dependencies here and then put them in the right location. We have also no control about if these dependency versions are correct or not. So they are basically up to their own, heading to some website, grabbing the right artifacts, extract them in the correct location, and then start the project and get these artifacts as well in there. So there's also a second dimension to this, which is not necessarily the build part. It is the part of the development environment of the user. If we take a look at build and execution, we can see that there's two project libraries, and they point to the same location as the artifacts right now. So the user also has, so if the user places them correctly inside of this folder, they would be picked up automatically. But usually we do not recommend to check in this project library's XML file. Because it, as you can see here, it contains an absolute path, or you have to define a path variable so that it's substituted correctly inside of MPS, and it can be quite tricky to get this working in the right way, because usually when the user opens the project for the first time, he gets error messages from MPS telling him that he needs to set up some path variable. He doesn't really know where to point it because there's also no way to attach documentation to them. There's only a button inside of MPS where the user is asked to create such path variables that you can set here in the settings as well. But this is also not what we would like to do here. So we would like to automate all of this for the user, so that when the user checks out something from source control, he can basically run one command and then get all of the project setup done for him as well. So this also will help the user to work with your software and also to onboard new people. When you have somebody new coming to your project, we would like to give him an easy way to get started with the actual project. So what do we typically do to achieve this? What we do is we put a layer around the MPS build scripts. So we wrap all of the logic that is done in AND with Gradle. So Gradle allows us to resolve dependencies. Gradle allows us to get the to download the dependencies, to extract them in the right location, and then to execute the actual AND scripts that are generated by MPS. So let's take a look at one of these Gradle scripts. I have already opened one here in IntelliJ. Let's get this here. And we have one Gradle file here, which is quite large already. But we will go through this step by step and explain what it's actually doing and why we are doing this. So there's at the beginning there's a bunch of stuff, including some plugins, etc., which we don't really need to take a look at now. So I guess the easiest way to do this is we would actually start from scratch here and create a new one. That is a very basic one. And let's throw out some of the stuff that we definitely don't need now. So let's remove most of the stuff here. Let me take a look at it, what we need. So I don't think we need this at the moment. Okay. Right, let me undo this and create a new, rename this file. Template, so that we can go through all of the individual things that we do here. Okay, so let's create a new file. Call it build.gradle. Like this. Okay, and now let's add step-by-step things that we actually need. So the first thing we would need is this plugin here, which we have built as an open source plugin. It's also on GitHub. We can take a look at the GitHub page here as well. Second, move this over. So github.com header MPS Gradle plugin here. So this is a plugin we have built over the past years to streamline the Gradle and MPS interaction. So it gives you helpers for invoking tasks from MPS, and it also allows you to like create DMG files for distributing your own RCP and things like this. But it also has other nice features like generating these project libraries that we have seen before, and we will use all of this later. So how you edit is also described to your build script is also described here at the very top of the page here. So if we copy this block and we go to our build Gradle file here, we can directly paste this block, and then if we run here import again, it will automatically import the change Gradle file for us into IntelliJ so that we get code completion, etc. So if you see me clicking down at the right corner to re-import the project, this is usually done to get changes from the project back into the IDE. So there is the usual stuff like defining a group and a description, which is nothing special. So you usually do this in any Gradle project. So we define a group, which is basically the namespace of your build script. And we also give it some description, in this case, sample project for building MPS projects. And then there's a bunch of plugins that are applied here. We don't need to take a look at them now. What is more important is stuff that happens down here. So what we usually do is we create tasks for the individual AND files that we generate. So if we take a look at the AND files that we generate, it's basically 3. So one for the languages, one for the test, and one for the actual RCP. And the one for the languages here, we already have a task for it. It's called build languages. So let's take this here as well and paste the task. And now I have pasted a type definition here that is called build languages. And this is a task that comes from our MPS Gradle plugin, and IntelliJ has automatically detected that I would need to import a package to get this information. So we can just click OK here, and IntelliJ will add the required import for us at the very top here. We can now re-import the changes here, but we can now see that this fails. And this is because there is a dependency here that cannot be fulfilled. And for now, I'm just removing it. And now we get some more errors here because there's some default script arguments missing, etc. So let's take a look at what these default script arguments are. So this is defined here. So you can define what arguments you would like to pass to the art execution. And you can also define the class path and then the script file, etc. So let's take a look first at the script file, because this is the easiest to understand helper that we use here. So script file is basically a function here. I will also copy over and then explain what it's actually doing. Let's take it here. So script file basically takes some path and then adds this to some relative. So it takes the relative part for the output location where the XML files are located. So in this case, it's build slash so the root directory of the project, which is in this case MPS build example, and then the subfolder build, and then the relative path that we pass in here, and this is this de example build.xml. Okay. So then the second thing that we have here is these default script arguments. Also take a look at them, how they are defined in the template. So the default script arguments are a collection of AND variables that are defined for the process that we spawn to actually execute the AND files that we have generated from MPS. So all of these folders that we define up here end up as variables inside the AND build script. So all of these variables on top here in your folders, in your macros section, are accessible via AND. So they end up in a variable that you can also override from the outside world. And we will use this heavily to modify the locations of certain artifacts. And so what we can see here is that for all of these folder entries that we have in the build script, we can see that there is like one of these extension variables defined here. So they also have usually the same name as they have in the build script of MPS. So we have MPS home here, which if you would use the end syntax to override, you would need to pass in -D, then the name of the variable equals, and then some location. So let me take this one here. So let's see which we need. So we need artifact root, we need project home, the platform artifacts, open source artifacts, and MPS home. So we have project home here, MPS home, artifacts, location. Let's take those over here, and let's remove the build tier for now because we don't need this. And what you can also see here is that there is like that these things point to some variables that are defined in Gradle here as well. So the project root itself is resolved by root project, project dir, and then the absolute path. And then we create a file out of it because we need to do this in Groovy like that. And then set this to the absolute location where our project is located. For MPS home, this currently has some notation here that it depends on resolve MPS. Let's get rid of this for now and just add our absolute location that we have added before, or that we have seen before. So if we go here again, this was the absolute location where our MPS was located, and we can also add the surrounding parentheses, quotations here, so that it's a valid string that Arndt will interpret correctly. And then we also have like the artifacts root here as well, which points to the root project subdirectory artifacts, which is here. Well, I see this. We can actually replace this like this to make it a bit more streamlined. So the project home is basically the root location inside of the directory. And then what we see here is this is then our default script arguments. So let me just copy them over and then explain what they are actually doing. So let's throw out some stuff that we definitely don't have at the moment. So we don't have build date, we don't have plugin versions. We don't have build directory. So like this. So default script arguments is a list of our individual path macros or variables that we would usually pass directly into the Arndt subprocess. So, and the third thing we need, so if we now import this again, we get another error message here claiming that the build script class path is not there. So we just copy over that. Is working. Maybe we can also omit this for now. Move this and import the changes again. Okay, so now we can see that it's actually importing something. So we could use IntelliJ to just run this task directly, I think. Yeah, and it will now fail. Yeah. So if we now try to run this task, we get an error message that it cannot find the Arndt launcher. So we would like to execute Arndt, but it needs to be on the class path. How do we do this? So therefore we use Gradle normal dependency resolution mechanism. Here and remove all of the stuff we don't need for now. Then what we are doing here, so this and all of this. So what we have done here is we declare a dependency onto Apache Arndt and JUnit, which basically resolves us all of our dependencies that we would need to run Arndt in a Java process. So this also includes then the launcher class here. And if we go back to the template, I think still need to find our repository somewhere. Yeah, right here. Let's remove everything here for now and just depend on Maven Central. So what we would like to do here is we would just like to get our Arndt library from Maven Central with normal Gradle dependency resolving. And now this class path thing is relevant for us. So we take a look here at the class path, how it's defined. So the build script class path it looks into the configurations, into the ART library, and then collects all of the files from it. It also adds the tools jar, but let's ignore that for now. Just take this. And we'll also get class path here, auto completion. This. So we have our class path here that now adds ART or the ART library configuration, which is here, to the class path. And since in the dependencies section we have defined that the ART library should depend on or that the dependency of the configuration ART lib is ART JUnit, it will resolve this for us. So if we execute this, we hopefully get some downloads here. Yeah, exactly. So it's loading. Okay, so the download might take a bit. And it failed again. Why this time? Because the target. Okay. Yeah, we don't actually need those here, I guess. Because we escaped them in our plugin. Yeah, exactly. So what's now happening is that it is trying to generate our project. So what we can see here is that the generator is invoked, and then after generation is completed, so generate is pretty much finished, it then fails because it cannot compile the generated Java code. So what can we do about this? So this is the second part of the class path that we have here. So the tools jar is actually loaded onto the class path as well, so that the Java C compiler, etc. is available for the build scripts. So also add this, our build script here, and attach it to the append it to the script class path. One thing we need here is we need to get the JDK home, which we do some logic here in the build script. I will for now copy it over and we take a look at it later. What it's actually doing. But for now we can just assume that we need it. Okay, so if the project has no property JDK home, there's some logic that actually tries to find the JDK and then the tools jar located inside of it. And then later on we use the tools jar here to put it on the class path as well. And if we now run the task here, we should be able to see that it's now getting further. Let's see. Okay, so now the build is successful. Okay. But currently all of this is hard-coded, right? So somebody has to place the there's still a lot of manual work involved to get the build scripts working at the moment. So the user would still need to go to the artifacts folder, copy in the platform, copy in the open source artifacts that he has downloaded from somewhere else, and then run the build manually. And also take care of downloading the correct versions, which might be quite tricky. And the user also needs to adjust the MPS location in here, right? So this is also the path that works on my machine, but if a user has MPS installed somewhere else, the user would also need to supply the location there. as well. So how can we solve this? So this is easiest solved by using the dependency resolving mechanics from Gradle itself. So if we take a look at our template build script here and at the dependency section, we can see that there's an MPS dependency here, and that there's a dependency on MPS or on IATS3 here as well. So let's first try to get Gradle to download the correct MPS version that we want to use, and so that the user does not need to take care of this version as well, and there's no need in the build script to add any path that is dependent on the user's machine. So we can add this to the dependencies section, and now we can just have this version in here. This is currently still using an older version of MPS. It's not the latest, but we leave it like this now, just for the sake of the demo. It doesn't really matter. So we define a variable here that contains our MPS version. In this case, it's 2017 3.5. We are currently at 2018 2.4, which we could also use, but I will leave it for now at the older version. And then we also need to add a configuration for MPS to the configuration section up here. So here, and this as well. And then let's just re-import it for now. Okay. So our build script is still correct. IntelliJ now also resolves our variables here. So let's see that this is bound to this extra property, etc. But now there's nothing done with MPS yet, right? So we have declared a dependency, but nobody is actually using it. So how can we make use of it? The easiest, or the way how we do this is we have a separate task for dealing with it. And the task is called resolve MPS. So let's bring this over as well and then explain what it's doing. So the resolve MPS task here is a copy task. So it takes some input and then exports it, then copies the input to some output location. And right now we still have an error here that the MPS directory property is not defined. So let's take a look here where it is defined. So let me get those here. For example as well. Okay, so what we would like to do is we define the artifacts directory. So the artifacts directory here is in our root. It is the under the root the directory artifacts where we want to place all of our external artifacts, and then we want to place it into a subdirectory MPS. Okay, so import again. The import is now successful. And we can also remove this depends. This was only required in older versions. Okay, so what does our resolve MPS task do? So our resolve MPS task looks into the MPS configuration, resolves it, and then collects all of the content of it. And here it's a bit tricky because we know that this configuration will only return zip files. So when it's downloading this dependency MPS, it gets back a single zip file. So we use the zip tree here to extract this the content of the zip file and get it as individual files. So zip tree basically looks into the zip file and gives you all of the individual files in there. And then we would like to extract all of this into the MPS directory. So if we would run this now, it will most probably fail because Gradle has no means of resolving MPS at the moment. So MPS is not published by JetBrains into some into Maven Central, or a repository that is contained into Maven Central. So what we would need to do is we would need to get it from some other location. And what we have done as Itemus is we have a Nexus instance where we place all of these artifacts as well that you can use. So this is also open to the public, so you can access all of the open source code stored there. And for doing this, we have to add a Maven repository. Okay. And the repository URL is here, better. So in this embedder repository, we'll also find MPS. So if we save this, import the changes, and now execute the task here again, Gradle will also search into the new repository that we have added here. And this repository is located at projects.itemus.de. We can also go to the web interface here, I think. This and HTTPS. Okay, so like this, and even if you don't have a login, you are able to browse the repositories, and you can see that there is here these this embedder repository, but you could also just add the complete open source group, which is also includes embedder and an MPS here. So if we take a look at the storage here down here, you can see that there is a that the open source project group also contains MPS. So just for simplicity, let's add this single URL here because it's much more convenient. It contains all of the open source code that we publish around, or all of the artifacts that we publish around MPS, and also MPS itself. So Embedder is in there, IETS3 open source is in there, the Embedder platform is in there, and also the MPS extensions, which will supersede the Embedder platform at some point. So if we now run this resolve MPS task again, okay, in this case it tells us that it's up to date, so let's just delete our artifact here, see if it's still working correctly. So let's run it from IntelliJ. Yeah. Okay, and now the task is executed successfully. So what you can see now here is that the artifacts folder now contains the MPS subfolder here with a complete MPS installation or a complete MPS artifact in there. We can just use this in our build scripts as the primary location to pick up MPS. So let's do that as well here. So we now have the MPS directory, right? So our MPS home location is now simply the MPS directory, plus the MPS directory get absolute path, like this. So now we have defined a directory where we would like to extract MPS to. We have a task that is resolving MPS for us. And now if we want to use it, we can just use it from this location that is always the same and where Gradle takes care of putting this into the right location and also downloading the correct version for us. But we would need to do this before we can invoke any of the other tasks, right? So before we want to build the languages, so let's take a look at what would happen now. So I will delete the downloaded MPS artifact and just execute the build languages, build now, task now. And now it will basically fail with the same error message that we have seen at the beginning, so that it cannot load the task. So MPS home is not pointing to a valid location. But we pass it to some location, right? So the MPS directory is location, but this location has no MPS in there at the moment. So how do we fix this? It's pretty easy. So we can basically just say that this task that builds the languages should depend on the resolve MPS task. Run this. We should now see that it first tries to execute the resolve MPS task. Okay, it has done that, but the build still fails. Okay, this is now a problem with an old MPS version that we have downloaded, which can be quite a pain to debug, and usually you just know it by investigating it manually and looking at what error messages you get. So what we get here as an error message is that there's a property defined in the build script that the actual generate task does not support. And this happens when you have generated a build script with a newer version of MPS, where the generate task might have additional properties. But you execute it with an older version of MPS. So in this case, we generated it with my MPS that I have here on my machine. So this is 2018.2. But our download was still, so if I changes here, 2017 3.5. And this skip unmodified models is basically something that was introduced in 2018.1, if I remember correctly. And if we run our build scripts with an older version of MPS, this basically does not work. So let's save this again. So store the correct MPS version here in the build script. Currently, there's no real way to validate that you have the correct version of MPS running on the machine and the projects that you open. So if you open the project with a newer version, you don't get an error message or anything that tells you that the project was not supposed to work with this. So if you get into the situation that I am currently, so you have your local MPS updated, you have also updated the project itself, but you have not updated the build scripts to use a newer version of MPS, you might get into these situations where you get very hard to understand error messages, which is quite a pain sometimes. So there's currently no real workaround for this because a project does not store which MPS version it is using. So even if we have a Gradle script that does all the build composition for us, there's no way that this script could verify that the project is, or that the version of MPS that is used to build it from the command line is actually the one that is also used to edit it. So if you use an older version to build against it, you might end up in exact this situation, that you get a weird error message that only tells you something is missing, or in the worst case, you could also just get some compilation errors because some classes are not there, because there's currently no checking done whatsoever if your MPS version matches with the version of MPS which was used to store the project. Okay, so we have stored this. I think yes. So if we now rerun the build task, we can now see that it needs to download the newer version of MPS, which will take a bit here. I guess check. Yeah, it's downloading. Okay, so while this is downloading, we can also take a look at the other things we still need to do. So after we have built our languages, we would also like to execute our tests, right? So executing the tests would be a second task inside of our build script as well. So so in that case, we can first verify that our project is building correctly and then execute the type system tests or any other kind of tests that we have written for our languages. Okay, so this is successful now. So we now have a build script that downloads the correct MPS version, extracts it to some predefined location, and then executes our build script against it. Okay. So the next thing we would like to do is to add support for executing our tests that we have. So inside of MPS here. Oh wait, before we do this, the next thing we would like to actually do is to download the correct version of IETS3 that we need. So we don't want the user to require to download the Embedder platform and the IETS3 open source distribution as well manually, right? So we would also like to automate this. And we can do this in the same way as we did with MPS. So we create a new configuration here. We usually tend to call them MPS artifacts because they contain all of the artifacts that have been produced by one or multiple MPS build. So the MPS, so we tend to package them all in a similar way so that the user can actually get this in an easy way. And to do so, we have first added our configuration up here, MPS artifacts, and now we need to add a dependency. And instead of using a variable here, I'm just doing this like that. So the variable in the template is for more advanced use cases where you actually want to override the IETS3 version that is used from the outside. So this comes handy when you would like to verify that your project also works with a newer version of your dependency. But there's also other ways to do this, basically by using dependency log or something like that. But we will not cover that today because it would basically exceed the scope and make this even longer. So what do we want to do? So we want to download an IETS3 open source version 1.0 plus. Okay. And similar to resolving MPS, we also need to resolve this dependency. So let's go back to our template build script, and there's already a task that there's a task for this. So we call it resolve dependencies, and we will also place it in our Gradle script. So what does the task do? So the task here goes to our okay. So this task goes to our configurations, then to the MPS artifacts configuration that we have just created up here. Resolves this configuration and collects all of the content from it as zip files. This zip3 here is hard-coded. There's also ways that you could detect if it's a zip file or not, what you have downloaded from the Nexus, but we know that we will only publish zip files for this MPS artifacts that we put into Nexus. So they are a single zip file that contains all of the content that you need. We can also look at one of these files from the web. So if we would go back here and go to com embedder, for instance. Oh no, let's go to IETS3 to get the exact same thing that we need. So this is org IETS3 open source. Then whatever, let's pick some version here. This one. And download the zip file here. You can do this manually. It will take a bit. Okay, 36 megabytes shouldn't take so long. Okay, there we are. So when you extract the zip file, you basically get a folder with the flat structure how you could also load this as a project library inside of MPS. So what you get from Nexus is a single zip file with all of the content that you need. And we just use the same behavior as what I just did. So we download the zip file and then automatically extract it into a predefined location. And since all of these zip files contain a root folder that is named after the project they contain, so in this case it was IETS3 open source, it is automatically extracted into the right folder. So if we run this now, for now I will delete the already existing artifacts here that I have put there manually before. Let's delete them and see what happens if we now run the resolve MPS artifacts task. What we can see here is that there's already some downloads going on, but it's also not only downloading the IETS3 open source part, it's also downloading an embedder platform here, as you can see. So why does it happen? The reason is that artifacts in the Nexus can declare dependencies, and we basically use the fact to declare these dependencies to resolve them automatically. So if IETS3 introduces a new dependency, you automatically download them as well. So there's no need to define them or to manage them manually. So you basically get an automated way of doing this. So what we can see now is that the embedder platform was extracted, and the IETS3 open source part. So if we take a look at what how this happened, so we can see that Gradle has downloaded the metadata, and then the usual POM file stuff that you are used to work with normal Java stuff also works in here. So if we take a look at the POM file from here from IETS3 open source, It's formatted in a weird way here. Let me download this manually. And then let's open it. Source. So the POM file here is a normal Java POM file that we are used to get with other artifacts as well. And here we declare that we have a dependency on the Embedded platform. And this is also the exact same version that this version of IETS3 open source has been built against. So you are always sure to get the correct content or the correct version of your dependencies. Of course, you could overwrite this and say, okay, I have a specific version of the Embedded platform that I need to use because there's a bug in a newer one or whatsoever. You can also do this, but this is something that Gradle can do for you, and this is not really MPS specific. So the MPS specifics of it doesn't exist. So you can basically just go to the Gradle documentation and look for forcing dependencies to a docs.org, and then there's somewhere force dependencies, I think. Dependency management. Where's dependency management? Here. And then there is customizing the resolution behavior. Where you can basically use all of the normal Gradle logic to customize what versions you would actually like to use. Define substitution rules, etc. How you can replace existing dependencies in your project and so on. This is nothing special with respect to MPS here. Okay. So if we now want to run our build languages build here, it currently only depends on resolving MPS. But of course, we also wanted to depend on extracting the artifacts from IETS3 and its dependencies. So we add this to the depends on section of the artifact. And now I will just clean the complete artifacts tip directory. Remove everything from there, so we are in a completely clean state. How it would look on a machine where the user just checked out the repository too, and then just invoke the build languages build here. So this is now executing the resolve MPS task first, extracting MPS to the location where we would like to have it, and then the artifacts. Was quite quick, and now it's invoking the build. Okay, so this was successful. And then the next thing would be to add the test execution to our Gradle script as well. And we can also take a look here. Usually call it run tests. And here we use another task type, run the importer. So the run test type task is of type test languages, which is also a task that is contained in the MPS Gradle plugin. And it's used to execute build scripts or unscripts that are generated from MPS that are supposed to contain tests like JUnit tests or type system tests, etc. So if we take a look into MPS, it will now re-index the files because it has noticed that there were changes to the jar files that we have that we are using as project libraries. So this will now take a second, I guess. Okay, so while it's indexing, we can take a look at the test build script inside of MPS. So what we have executed so far was the build example part, which is only building the languages. So it takes the languages and then packages them so that you can reuse them somewhere else. This. Okay, so indexing hopefully finishes. Yeah. Okay, so the build example part, or this build script, the build definition here in MPS that ends up in the build XML that we were currently executing. There's one group in there which contains the two languages and the runtime solution, and then packages all of this into a IntelliJ IDEA plugin so that it can be loaded in some RCP. Set some other settings here, like the MPS settings allow you to define how much heap space the JVM has that you would like to use for generating. I think the defaults are quite low, so let's take a look at them, what they are by default. By default, the JVM only gets 512 megabytes of heap space, which will slow down your generation quite quickly. So we usually run this with at least 4 gigabytes of heap space, so that you get a decent performance even with a somewhat bigger projects, because at some point 512 megabytes will definitely not be enough, and if you're running this in CI, you should have enough resources that you can actually use them. We also have some projects that use quite bigger heap spaces, like 6 gigabytes or 9 gigabytes. Apparently there's no way to set this from the Gradle outside world, so changing this value in CI and on a developer machine can be quite a challenge. But I guess we can take a look at that at some later stage. Okay, so now we have a second build script here that is that contains the tests. So test here is a very simple. Press one button here to get rid of this error. So reloading all classes basically invalidates all class loaders from MPS and then reloads the jar files, and we have an error here, which is most probably why it's not working correctly. Yeah. Okay. Will most probably also fail my tests, I guess. 1 second. Let me build this from within MPS. There's something. Okay, it does not. Let me just restart MPS. Or at least reopen the project. So the problem here was that I loaded some older dependencies into, yeah, now it's working. Okay, so as we have seen before, I think I copied the wrong version of IETS3 into my artifacts repository. So that was the reason why it wasn't really working. And you got this weird class loader exceptions when it tried to instantiate the the library from within ITS3 at this point. So the test here is a very straightforward MPS node test. So it contains one node with a check annotation that it should be checked for error messages, and it contains a single expression which we expect to have a warning. So if I remove this expectation, currently seems not to work. Interesting. Okay, so the test should fail in this case. Okay, so let's remove the check annotation for now, and have it like this so that this test would actually succeed. So this is the very simple test solution. It also contains a test info, and test info is usually required by MPS to be able to load your artifacts or to load the testers from the JUnit environment where it's executing them. So what the test configuration contains is a path variable to the project that should be opened. And it supports also using path variables inside of this path description. So the test info contains the path where the MPS project is located, which is required to be loaded to execute the tests inside of this model. And in this case, we use this project home variable. And if we take a look, and this is also the reason why this was supplied here in the Gradle build script, where we would like to define this project home to be available to the AND task. And if we now take a look at the build script that is used to execute these tests, what we can see here is, first of all, it has like the same structure of folders, at least on the first side. So we have the artifacts location, the project home, platform artifacts, ETS3, MPS home, etc. But there is one thing here which is not in the normal example build script, and this is here this weird looking folder definition. So what we do here is we need to define a variable inside of AND that the MPS test execution can pick up to fill in the path here in the project library, in the test info, so that the test info project path is pointing to the correct location. And at first you would think, okay, I can just define a variable inside of AND that has the same name as the one that I used in here, so that I don't need to place an absolute path in here when I create the test info, but this doesn't work. So MPS has some special logic hidden somewhere inside of how it handles these path macros. So a path macro that you could define inside of your IDE here, and which is then used in the test info, is something different than a variable that you define here as a folder macro, for instance, inside of the build script. So what you need to do is you need to prefix this with mps.macro and then the name of the path variable that you would like to define. And in this case, this is project home. And then we assign this end variable to the project home variable that you get from that is defined up here. Okay, so what else is in there? There's a dependency section, as in every MPS build script, which declares what dependencies we need to load. And we also have a dependency to our other build script. So the example build script, which we had a look at before, which contains our two languages and the runtime solution. Okay, then we have generator options, Java options. We can go over them a bit later. They don't really matter for now. And then we have a solution in here, which is referencing our test solution. So this is the test.de items MPS build example language A. And this is basically the same here, which we add here as a solution. Then what we also do here is we declare an idea plugin that contains the test solution. This is required so that MPS can load the correct dependencies at runtime when it's executing the tests. Most of the time it will work without, but sometimes you will get weird class loading errors that it cannot find certain classes, or that it cannot load a plugin or something like this. And if you see that, you usually need an idea plugin inside of your build script. It only needs to be there. You don't need to do anything with it. But this is then enough for MPS to pick up, for instance, dependencies that you need. And in this case, we need to make sure that MPS util is loaded. We can remove this at some stage and then see what the error message is. But in this case, we needed it to make sure that the build is actually working. Okay, then we have a default layout section, which has, nothing special in it. So it only contains the single module here that we have defined. So our solution that contains the tests. But then comes the interesting bit here that you need. And this is the test modules configuration. So this configuration tells MPS which tests it should actually execute. And there's one really common pitfall here. And the first one is, so if I remove this, and I also remove this plugin up here, and now I press Control Space, I don't see anything here that is related to tests. So what you need to do is, in the plugin section of your build script, you need to include the module testing plugin, which then allows you to go to the additional aspects section, press Control Space there, and then get the test modules settings. Okay, now you can give the test configuration a name, so you can also have multiple of them. If you, for some reason, want to modularize your tests more and have them show up in other tools as really different test configurations, you can do that as well. For MPS, it doesn't really matter if you do it, because it's just a name that MPS uses to name the resulting JUnit XML file. So in our case, I will just call it samples. Tests. And in the section below, you can reference modules. So first of all, so that the module shows up here, you need to have it. It needs to be part of the default layout. It does not, but you will get an error when you try to generate, I think. Try this here, actually. Where's my... One second. I think. For whatever reason, I cannot build at the moment. Is there anything going on here? Okay, let me just restart this. Okay, so restart it and let's reopen the project. Migration here doesn't do anything. So this migration is when MPS detects that you have changed dependencies somewhere. It's also updating the upstream or the downstream users of the language. So if you have like language A that is used by B and you change the dependencies of A, it will also automatically update them in B. And this is what you get with this update module descriptors migration. So now my make menu is back finally. So let's call this here example tests and include this, but remove it from the layout. And now you get this exception that there's an MPS module that is not found in the layout, which you will often see when you are missing something in the layout section of your build script, which is then used by other parts or that other things depend on. And in this case, we are missing the module that we want to test in our layout section up here, so we cannot really reference it from the test modules configuration. So when a generator tries to generate it, we get an error message. The really sad thing here is that this could actually be checked directly in the editor, right? So if it's something that is referenced from here, and we remove it from the default layout, we could get an error message here, which would make much more sense than first run that generation here and then get some error message that something is missing. Okay. Let's take a look at, so let me show one thing here as well, which is often a pitfall. So let me only copy the path here so that I don't type it. So if we would start normally, we would add a solution here, right? So not give it a name, but just define where it's loaded from. So we would like to load it from code solutions, I guess. Test solution, and then the MSD file where it's in, and then use the reload modules intention to extract the information here. And now we would like to put it here and here. But now we would like to reference this solution that contains our tests in the test modules configuration, but it doesn't show up. Why? The problem here is that if you go to your solution and you open the inspector on it, what you can see here is that there is a content section in it, and it says it packages the sources. But what you need is sources and tests, because otherwise all the models with a stereotype test will not be packaged, and then it's not visible down here in the test modules configuration. So if we now go here, it will show up like this, and we can select it. Okay. So this is our build script that describes in MPS what we would like to do. So we would like to first build our solution that contains the tests, and then we have a test configuration that we would like to execute that runs the tests that are in our solution. We can now generate this and get an ARN script out of it. So the ARN file here is called build-tests-xml, and it's in a similar fashion than the normal ARN files that you get generated from MPS. And what we need to do now is we want to invoke the tests in here, right? So we can also do this from the command line manually, like we can do this for the build itself. So we can also do that here. Okay, so can also run this wire on the test XML. Okay, and then I think it's the test target in there that we need to invoke. So what we tell Arndt here is to load the file build test XML, then give it a target to execute, and then define some variables. In this case, I'm just referencing MPS again with a hard-coded directory for now, just to see if it's working from the command line. So it seems to be working. So what we can see here is that there's quite a lot of output from JUnit. So JUnit is booting an MPS. So there's a JUnit task that starts an MPS, or at least a bare minimum MPS, and then is executing the tests. And hopefully they are successful. So let's take a look. It's now loading the temporal project. Okay, initializing the tests. And something has failed, I guess. This is relevant to it. Okay, this is also one of the things here. It's quite hard to figure out if something is really an error message from within test that is failing, or if it's an error message that you can safely ignore because MPS tends to spam the log with a lot of stuff. So, but I think we have a problem here. Yeah. Okay. You can now either read the complete output, or MPS also generates a JUnit XML file for your test executions. So in that case, you can go here, open the XML file directly. Did load of properties, and then the errors that we got. Okay, for whatever reason, there's a class loader that cannot load some of our dependencies. Nice. Okay. And MPS, just to see that it's not a conflict with the integrated web server, but I don't think it is. It's handled. Okay. Nope, I think it's still failing. Yeah, test suite failed. It cannot load the model listeners. Okay, so this is one of these situations where you really need to know what MPS is doing behind the scenes, because what's now happening is that MPS in the test tries to initialize some of the plugins that you are using, but cannot for some reason determine the correct dependencies. So what happens then is that you get all of these class loader exceptions here, so it cannot load, in this case, the MPS model listener runtime. And I think it's the model listener runtime that cannot be loaded in this case. Okay, so what can we do about this? So this is the reason why there is this idea plugin in here. So there are two things missing here. So one thing is that it cannot load the model listeners runtime. The second problem was that it would not load ITS3 stuff. Okay. This is the plugin that contains all of it. Yes. So let's see if this actually helps. Hopefully it does. Nope. Data on test suite still fails. There's one thing we can do. Show which plugins fail to load. Thing we can do is see if that works. Let's see. Really working. Okay, the test path. Okay, this is weird because the test suite execution says that it failed, but the actual test has passed. So if we take a look at the XML file here, the test suite, and then a test, and the test was successful actually. So this is our my test. Here it failed. Okay, it actually has a warning. Okay. Okay, so the test fails because it should actually fail. And it's not a problem of the build script, so we can remove this here. And go back to our test. And then say, there's warning annotation here. So this will now change the test assertion to expect that this node has a an error message. Let's rebuild the test script, the build scripts. And execute this again. You don't really need to rebuild the build script in this case because it should also work without doing that. So let's see if it's now successful. So this is one of the problems that you can encounter when running the tests from the command line within MPS, because it sometimes behaves in a slightly different way than it does from the IDE, and on the test. XML file. Okay. Okay. Oh, this should. Let's try something. So let's try to run it from the IDE first to see what happens here. Be sure that we get a consistent result on the IDE and on the command line as well. So there's the run test button here that you can use. Wait. Nah, it fails because of the test info here. Nice. Then we remove this. Nope. Okay, let me just remove the test info for now. Get it working from the IDE. Okay, now it fails because it has no test info. Could also work without it. No, still complains that it wants to have a test info. Okay, then let's give it back a test info. And the test info, the normal path here. And just for now, I will define a path variable inside of my MPS that points to this exact location where the project is located. Here. This should then. Okay, so from the IDE, it now works. Can execute the tests successfully. So let's take a look what happens from the command line. Let's call all of the tasks here from the command line that we need. So what we want to do is we want to generate, then assemble, which calls the Java compiler on it, and then execute the tests on the compiled artifact. So these are usually the three tasks you need to invoke. So if you just invoke the test task, it will blindly execute the test without regenerating or recompiling any of the code that you have in your test. So you always need to make sure to execute these tasks in the correct order, or at least tell Ant to execute it, not really in the correct order, because ordering will be done by Ant itself. So let's take a look at the file here. Yes, but we are asserting that this should be the case. For now, execute the test again from the command line. If it now doesn't work, we will go on with the normal build scripts, because it doesn't really matter if the tests are now successful or not. We just want to show how we can invoke them from Gradle and manage the dependencies correctly. So project is open. And it's failed. So no idea why. This case fails, and the other one is still successful. Yeah. Interesting. Okay. Let's for now ignore this from the command line and dig into that a little bit later. So what we want to do is we want to basically do this AND call here that passes in the correct path to MPS and to the AND file that we would like to execute. We would also do this from Gradle as well, and also pass in the correct location of the of IHS3, etc. So for this, we have here a run test task that is of type test languages, and yes. So what this task does is it's a task that we provide. It's not decompiled from the class file. This is why it looks a bit ugly. So we can also go to the original code here on GitHub. So if you would like to take a look at how our custom tasks look like, so this is the test languages Groovy file that is used to compile it. So this is extending a run unscript task and basically says we should invoke the tasks clean, generate, assemble, and then check. And the run unscript task here is a task that is basically invoking the Ant launcher in a working directory, passing in a given class path, and then adding the file and the arguments of the script here to the Java process that we are spawning. So this executes Ant out of process of the actual Gradle JVM. Okay, so if we now go back to our build script, what we would like to do is we have our run test task. It takes again the default script arguments that we have defined, which points to the individual locations, and gets the same class path, and then uses the build minus tests XML file to build. So if we run this, we can also run it from in IntelliJ. This will now run the individual tasks, so we can see that it has already tried to resolve the MPS and the ATS3 open source artifacts, but both of them were up to date, so there was nothing to do. Now the languages are rebuilt, so currently there's no real support for incremental build when using Gradle and MPS in conjunction. So MPS recently introduced a way of only rebuilding models that have been changed. So you get some kind of incremental generation from the command line, but Gradle is not really aware of it. So Gradle will anyway invoke the build languages task because it cannot check if it's up to date or not, and then give you the and then execute the task. And if we would turn on incremental generation from the command line within MPS, MPS would then only generate the models it really needs to generate. But for now, there's no real support in doing any of this from the Gradle level. So we have to start a JVM that boots up MPS anyway. Okay. So now we can see that there's quite a lot of output down here in the window. And interestingly, seems now that the tests were successful. Let's take a look. Or maybe it's just not shown here because IntelliJ truncated the output. Let's take a look here and let's run this from the command line here. So the project uses a Gradle wrapper. So we can just invoke Gradle W as a script here from the command line. And now it will try to generate and build our project also from the command line and not only from within IntelliJ. So both of the ways work. So if you need to debug something in your Gradle scripts, it's quite nice to do it from IntelliJ because you can set breakpoints and see what's going on and say you would like to debug one of the tasks here. But if you just want to build things, you can also just do it directly from the command line. Okay, so now it's initializing the tests here as well. I think in total it will take up to 1 minute 30 seconds. There's quite a lot of overhead in booting MPS, etc. So this is usually not happening in case. Okay, our build is now successful, so the tests execute. I'm not sure why this is now. I guess because we are now invoking the clean task, and we might have some outdated artifacts somewhere that were used. So let's see. Okay, so this now also works. So we can now also run our tests from the command line. We can try here and try to make the test fail again. So if we run this from inside of MPS, we now get an error here that the test failed. One test failed. And now let's see if we can verify this from the command line as well. Okay, so while this is building, we can also take a look at the RCP build scripts that we have, which are a bit more elaborated, I think. Well, not really. So in the RCP build scripts, you basically package your own custom MPS. And in this case, we just build a single, I think, Windows distribution in this case, yeah. That contains everything you need from MPS to have your standalone MPS here. We are also packaging a JDK. This might be interesting because we can. This is not really documented anywhere how to do this, so we can take a look at this as well from within the outer Gradle build script, how we define where the JVM is downloaded and where it should be placed. It's pretty straightforward, but we can take a look at that as well. For whatever reason, the build is the tests are still failing here as well. Okay, but this claims, okay, so yeah, the return code is still 0, so we don't fail really. Take a look here. Okay, yeah, the test still. Okay, now they are. The test is successful. Even if I have a warning here. Might be that the type system is not executed in the because this is a when concrete warning, it might not show up in the actual generated in the command line execution. Yeah, so maybe this is not the best example to test this. But we will leave it like this for now. So at least we know how to. I could show how to invoke your build script in the correct way to get your tests working. Okay, so the next thing I would like to show is something that we typically do in more advanced setups to keep our build scripts up to date. So one thing that we haven't really talked about yet is that these generated ARNT files, if you would like to run the build from CI, you have no way to get these 3 files, right? So, I mean, you can check them in, of course. So you can generate them on a developer machine, and you could then use these XML files somewhere else, right? So before, if you want to build your MPS project, currently what we would need to do is we would need to check in this 3, or at least the build test XML and the build XML file, because these are the 2 files that we currently use from from within Gradle here. So here we reference the build XML file and here the build tests XML file. And these two files would need to be present in order to be able to build the project from the command line. One way of doing this is to check in these generated files and then regenerate them every time you change something in there. But if you forget to regenerate them, you will still execute the old build scripts. In the simplest case, you're just missing something, right? So you're just missing a new solution or a new language that you have added to your build script. So if you add a new language here that you reference and you don't regenerate the file, this language is missing and it's not in your distribution. But what could also happen is that would be the best case actually, because it's not really an error during build, you're just missing something because your build script is not up to date. But what could also happen is that you change dependencies. So for instance, your language A here in this case gets a new dependency to whatever base language in this case. So you add a dependency to JetBrains MPS base language. Not really using it at the moment, but here you can see that it's now getting red, right? So in this case, if you don't regenerate the file, this dependency is not available to be loaded at runtime. And as soon as you are using it somewhere in the build, so as soon as there is a behavior method or an extends relationship here in one of the concepts, this will fail with completely weird error messages at runtime, because you might get class load exceptions, you might get error messages that some concept isn't loaded in the registry, etc. And they can be pretty hard to debug, because once you regenerate the build file, they are gone. And it's even if you execute the intention here, right? So if you say reload modules from disk, MPS extracts this new dependency automatically for you. Take a look at the inspector. Down here, we can see that the dependency to base language was actually extracted. But if we do not generate this model again, we will not get this dependency in the build XML file. So how can we solve this? So one thing is users would have to regenerate these build files all of the time. You could write some script that does it when you commit in Git or something like this, or other ways of automating this. But ideally, we would just like to generate these build files at the point where we are actually executing the build on the command line. So each time we are executing the build, we would like to regenerate these files. So how do we do this? We create a build script for them. So this is just a normal solution. It contains one model. And in this model, we have quite some MPS build solutions, they are called. And what we can do is we can basically write another solution or create another solution here that has a single model. And this model has a build script or build solution. Yeah, it's a bit confusing because, or build project, yeah. So MPS calls it build project. We have a solution here, which we call all scripts. Okay, so it's the same name as the normal build, but it's called build.all.scripts. It contains a single model. This model has a build project. And all what this build project is doing is it is referencing the other build solution. So we have some kind of meta build script, so to say, that invokes the generator on the downstream build script that we would like to use to execute our our actual project build with, right? So this is somewhat the meta layer on top of it. That is then using this this workaround to ensure that our generated XML files are always up to date. And we still need to check in the one generated ARN file, but in this case, it's only the generated ARN file from the all scripts XML, from the all scripts solution. And this is not really going to change a lot, right? So only if we really introduce a new build solution, this is actually going to change. Also, there are usually little dependencies involved here, so usually it's enough to just have MPS. I think we could safely remove those two here without having any problems. So the build script itself, the generated XML file, is pretty stable. Usually we only really regenerate them when we have MPS updates, or if we introduce a second build solution because we want to modularize the build further, then these solutions would need to be updated. But usually this is a pretty stable thing. It only contains one reference here to the solution. And then this solution, this build script will invoke the generator for the other build script. So it's so to say a meta build script. Yeah, so this is what we usually create as a pattern. So we have this meta thing that is used to generate the actual build scripts that we then want to execute. And now we would like to hook this up to our overall Gradle workflow. So in Gradle, in the template, I think we already have something here which we can use. Yes, all scripts is here as well. Can drop this in here. So the idea behind it here, as it's already written as a comment, is that this is trying to generate the other build scripts before we are actually running this. We are running them so that we always ensure they are up to date. So here we need to add another dependency because we only want to execute the languages build after we have executed the all scripts build. So let me now import the changes here and run the all scripts build. Okay, so that executed successfully. So let's also take a look at the location where we are loading these scripts from. So the script file function that we have defined up here, we use for conveniently referencing relative files, looks into root directory build and then the relative path. So this is here, build, then the relative path for our example is the item is MPS build example, which is here. So let's just delete that because this is the actual thing we would like to generate, right? So let's drop this. Okay. And now let's rerun all scripts. And once it's successful, should see that it has created the folder again. Yes. And it contains the 3 XML files we expected it to contain. So build tests, and the min RCP. Okay, so what we now just need to do is we need to check in this single file. So the all scripts build XML. This needs to be part of VCS because this is the minimum thing we need to bootstrap our build. But we do not need to include the other files. So we minimize the things that we actually need to check in, and we also minimize the things that user needs to update manually. So for us, we are doing this for, I think, 3 or 4 years now, and it has really proven to be a good approach. It helps to prevent these stages where your build scripts that you define inside of MPS as a model and your actual artifacts are going out of sync. Yeah. Okay. So what we have now is a build script that takes care of downloading the correct MPS version, downloading our dependencies in the correct version, then setting up the class path correctly and defining the variables where to find the dependencies, where to find MPS, etc. Then we have some tasks to actually resolve the artifacts we are looking for. And then we have tasks that are used to build the individual parts of our project. The first thing is what we do is we try to generate the actual build scripts that we want to execute later with our meta build script. Then we have a task that is responsible for building our languages, and a third task that is responsible for running our tests. Okay, so far so good. This would now allow us to build the project from the command line. Let's close the project in MPS for now. Go to the command line here and do git status. I have a lot of class scans still here. Why? Ah, okay, they were accidentally checked in before. Let me remove them from the git index. Show what is actually. Oh. There's also test. Okay, so there's some more class skin. This class skin here. This. Remove this as well. And what's also left here? There's some more source skin caches. And one more. Two more. Okay, another class skin. So these are all generated artifacts that you shouldn't really check in. I think they got checked in because the gitignore file wasn't really up to date. Source skin. And okay, this is valid. This is another caches directory which we should remove. Okay. And one more source scan cache here. Okay. Oh, one more. Okay. And source scan. Okay, so we don't have any checked in files here anymore. And let me just edit the git ignore file to also ignore these files. Source scan caches, source scan and test scan need to be part of the git ignore file. Otherwise you will check in generated artifacts pretty easily like I just did. Okay. Okay. Now we can check in everything here. Update to MPS 2018.2. Oh. Is okay. So what we can do now is we can first check if these files are not part of the git index. This one is, I guess, yes. So if we now do a git clean -fd, this basically removes everything that is not in the git index. In a clear state now, yes, exactly. And if we now want to open the project within MPS, restart MPS. There it is. Now you can see that there are quite a lot of errors because none of the dependencies can be found, right? So even if the user has now a build script or something like that for it, what still happens is that if the user wants to just open the project to get rid of these errors and to make MPS successfully load the project, what we need to do here is currently is we just go here and invoke the build, right? So if we say build underscore languages, languages, this. So now if we invoke the build, what implicitly happens is that we also resolve the dependencies, right? So we have the tasks here that are responsible for building all scripts, etc., and for also resolving the dependencies like MPS, etc., so that they are placed in the right location on disk. Okay, now our okay. Yeah, this is something I also wanted to show later. Just to get the build passing, create one directory here that is empty. Okay. But it should already be enough to show what I wanted to show. So in fact, that you now still get the error messages, right? So the project does not know where to get its dependencies from. So what we now would need to do manually is go to build execution, project libraries, and then, I don't know, here it's called IT3, build example, artifacts, have it point here, and then wait for MPS to load it, then go to better and add a library manually as well here, like this. Then here's this hopefully indexing the files now, outputting it. Yes, okay. And now the errors go away, right? So this is what the user would need to do currently to get everything into a working state. So manually invoking the build from the command line and then setting the project library manually. So it would be quite nice if we could simply automate this step, right? So we could go there and simply have one task that the user could execute from Gradle that doesn't require him to build everything, because we just don't want to build all of this. I mean, the user could go there and simply call the resolve MPS artifacts class task manually. So instead of doing what I just did, the user could go here and say, instead of invoking the complete build, the user could only just invoke the task that is responsible for resolving the dependencies, right? So resolve MPS artifacts could do that as well, and then set the actual path variables to something that so the project library, etc., to something that he can actually use. And in the other hand, we could also just check in the project libraries file, but all of this has the problem that we might end up with machine-dependent paths in there. So what to do against this? We have a task in we have helpers available in the MPS Gradle plugin that we are referencing here. So if we take a look at the blade file, this very quick here, and paste the relevant code and add the dependencies. Okay. So what are we doing here? So we declare a task that is called generate libraries XML, and it's of type generate libraries XML, obviously. And this task is responsible for generating project libraries for the end user. How does it work? So it takes two input files. The first one is the actual project libraries you would like to auto-generate. Here, this if we take a look at the libraries file that MPS has created. So Yeah, we need to something here. Actually make this work in the expected behavior. So I would like to remove this. Then MPS should eventually resave the file. Yes. Okay. So if we have now path variable defined that points to the project root, etc., what happens out of the box is that MPS determines a relative path from the project directory to the artifacts that we want to use at the project library. In this case, it's project directory, then one upwards, and then artifacts, and here IETS3 open source for the IETS3 library, and for the Embedder library, it's Common Embedder platform. So what we do here is we define this project libraries.properties file, which is a key value pair. So the key is the name of the project library we would like to define, and the value is the actual location where it should point to in the notation that MPS understands. So we can use path variables in there. We can also use like the special variables that MPS supports out of the box, like project dir, etc. The easiest way to get to these values is by looking at what MPS has actually generated into the library's XML file here. And just copy the value, which is here the option path value which you need to copy. Place it in here as the value for your project library's properties file. Give it some name. The name doesn't really matter. You can choose any arbitrary name, but it might be good that it has some relation to the actual content where it's pointing to. So this is the first file that this task takes as an input. And this is then used to generate this libraries file for you. So this is, so as a default, you need to reference this properties file, and then you can say you have a destination where it should put the project libraries generated XML file. In our case, it's in the code directory in the .mps directory inside of the code directory, which is our location of the MPS project. This might vary from project to project. But why are we doing this and not just checking in the project library's XML file, right? It's much easier to just check in the XML file with this relative path in there and have it like this. Why do we actually generate this file? So the interesting part is the overrides file. In my case, I don't have it yet. So the overrides file is a file in a similar format than the project library's properties file, which is our default file here. But sometimes you are not working with everything from generated artifacts. You have dependencies that you want to include as where you don't want to use generated artifacts from, but where you say, okay, I would like to actually reference them as source code inside of MPS so that I can easily work with the development state of an upstream dependency, for instance. So you can achieve this by basically overriding the project libraries. And this is what you then would place in the project libraries.overrides properties file. It has a similar format. And if you reference it here as a overrides file, the task looks into this file after it has loaded the defaults and then overrides the values of it. So if you have some dependency that you want on your developer machine to include from source, you can easily do this by defining these project libraries overrides. Usually we do not check in the overrides, but we check in the defaults, right? Because the defaults are the things that you want to distribute to all users. This is what you get some sane defaults. You end up in a state that you can always use, but in some cases it's much more convenient that some developers of the team will use source references to some of the dependencies that you have. And now one could also say, yeah, then just let's define another project library or redefine it all the time that it points to the right location. But this is quite error prone, and it's also like something that often prevents people from onboarding in a project. So if you say just run the generate project libraries task, which we won't run directly, we'll come to that in a minute. But this is much, much easier than actually copying stuff around, setting project libraries from within MPS when it's in a state where it has a lot of error messages, etc. It's, at least from my perspective, is much, much better to do this from the build scripts so that you initialize the project in a sane way. Okay, so let's take a look at that as well. In the template here, we also have a second task, so generating the project libraries file is not really enough, because in most of the cases we just don't only want to generate the project libraries file, but we also want to resolve the MPS libraries. So the artifacts that we need where these libraries are actually pointing to. So how to do this? What we do there is, in all of the projects that we do, we have a setup task, which is a convention that you can simply rely on. And the setup task contains everything you need to have to get started with the project. In this case, what the setup task is doing is it's first resolving the artifacts, which is our dependencies, and then it's generating the project libraries XML file. So let's try this. I will go here and delete the libraries XML file. Delete. Okay, like this. And now I will just execute the setup task. And this is usually pretty quick because it's not doing much, right? So it's just extracting some zip files. In this case, they are already up to date because the output is still there. And then it's generating an XML file out of these, out of the content from the properties file. So let's go to the to MPS and see what happens. We can also close the project again if we want to, and then reopen it here to just be sure that it reloads the libraries XML file and does not take some cached values here. And as you can see, the project is automatically in a state where you can just work with it, and there's nothing that you need to do as manual steps. So we can also verify that by removing everything from the repository that is not part of Git, like this, right? And now we close the project again. Yes, this is what actually happens if you delete the libraries XML file underneath an running MPS instance. And now MPS will not really like this. See, it claims that the project will be reloaded, but I think it will fail reloading because there's no libraries XML file present. In worst case, it will deadlock, but I hope it won't. Yeah, okay, we just see a bunch of class loading exceptions at the moment from the command line. Let's see. Okay, it happened what I tried to avoid. It deadlocked, so let's kill it. Okay, it really deadlocked. Okay, so let's restart it. Okay, so once it has restarted, where is it? Here. We should see that the project is now in the state that we expect it to be. So there's quite a lot of errors here that we can see. There's some languages cannot be loaded because their dependencies aren't there, right? So cannot find dependencies, extended languages, etc. Let's close it for now, and now go to the command line and execute the setup task. Okay, so this is pretty quick in execution, and then we reopen the project. And now the project is in a working state. This really helps new people onboarding projects. It's just so much more convenient when you just execute one task and then get the project into a state where you can directly work with it instead of fiddling around, having to actually add the dependencies manually, etc. Download the files manually, mix up versions, etc. So this can be quite a problem. I think that's it for today. So if you are interested in the actual code that we have used today, so it's on MPS sample. You can find all the code that we have that I have used today on GitHub here, which includes all the changes that we have done today. So it's in the same state as it's right now on my machine. And it also contains the template Gradle file, which you can, which is the full-blown example, which also includes some more advanced things like managing external dependencies that you use inside of MPS as libraries. So for instance, you would like to reference external jar files and things like that. And you would like to also manage these dependencies directly with Gradle, so that you all. This also has the advantage of allowing you to update dependencies with Gradle automatically. You don't have any checked-in jar files anymore in your repositories, etc. You can also take a look at that, but going through that now would just be too much, I guess. So yeah, I think that's it. So I hope you have a nice evening, and we will most probably do this again pretty soon. So bye.